Every year, the Centers for Disease Control and Prevention releases the country's most detailed report on death in the United States under the National Vital Statistics System. This mortality dataset is a record of every death in the country for 2005 through 2015, including detailed information about the causes of death and the demographic background of the deceased. There are a total of 11 CSV files, each containing 1 year's worth of data, which are paired with JSN files having code mapping. For this section, we are using 2015's data, and after removing the null values, the number of columns reduced to 29 from 77. To use this data, we are defining a function to read the JSON code files and store the columns as keys in dictionary. In visualization section, the focus is on visualizing the number of deaths on different columns related to causes, demographic, etc. First, we are visualizing resident status versus death count, and we found that the maximum death is of the people who reside there. To understand it more, we divide the data and group it by sex. After grouping, we found that the death of females are more than males in the residence status, but in non-residents, the death of males are more. Now we are visualizing race versus death count, and we observe that the death rate of white race is more as the population of the white race is maximum in United States. We created the death word cloud from which we found that the heart, malignant, and neoplasms are prominent diseases among the people. To understand the month of death and day of week of death, we created histograms from which we found that the rate of death is almost similar in all the months except January, and in day of week, it's almost similar. After visualizing the place of death, we found that the hospitals, clinics, or medical centers are the places where the most deaths took place. In marital status, maximum people who died were married. Here, the causes of deaths are reconstructed so that the similar causes are under a single group. From this also, we see that the same results as earlier. Deaths due to the heart diseases are the maximum. When visualizing causes of death grouped by sex, Alzheimer's is maximum in females and rest all other diseases were maximum in males. For this section, we look at the death trend from 2005 till 2015. For this, first we are cleaning the data and visualizing it. In this, first we see death number trend from 2005 to 2015. We can see it has increased. In death gender trend from 2005 to 2015, we can see in 2015, female deaths were more than males, but in 2015, it was opposite. For death race trend, we saw that the white race was the maximum. For distribution test, we will be looking at the distribution of number of age of death. From distribution test, visual normality test, we find that this graph is not very similar to the familiar bell shape, but it is a rough approximation that can be seen for some parts of it. In QQ test, there are big deviations in the bottom and the top with only a small part in the middle being close to the expected diagonal pattern. In statistical normality test, each test will return at least two things, statics and p-value. In k-square, p-value is equal to 0, due to which we rejected this test and proceeded for Ederson-Darling test. In Ederson-Darling test, the significance level is more than critical value every time and it does not look normal. That is why we rejected this test. Then we decided to do chi-square normality test where again p-value was equal to 0. After performing all these tests, it can be said that the distribution of age of death is not normal. In hypothesis testing, we look at different questions to analyze. First is average age of death in 2015 more than what it was in 2005? In 2005, the average age of death in US was 72.6 years, and our null hypothesis says the mean age of death is unchanged. But after this testing, the z value is obtained, which is more around 1.645. Therefore, the null hypothesis is rejected. In z test has proportion of suicides increased in 2015 when compared to 2005. In 2005, 1.33% of total deaths were suicide. But but in 2005 it has increased to 1.63. So therefore it has definitely increased in 2005 when compared to 2000 it has increased in 2015 when compared to 2005. In t-test, a difference in population proportion, who does Alzheimer's kill more, men or women? Female deaths due to Alzheimer's in 2015 is more than in men. It stands around 76888 and in males it stands around 33698. When applied machine learning algorithm, we tried to analyze who will die because of accidents. Here we are visualizing the deaths by accidents across different columns and found different results for every column. Now we will discuss about logistic regression and random forest. In logistic regression, the accuracy of the logistic regression is 0.63 and the precision of logistic regression is 0.68 and the recall value of logistic regression is 0.66. And in random forest, the accuracy level is 0.65 and the precision value is 0.805 and the recall value is 0.659. In both the models applied, The accuracy is decent with random forest having slightly better accuracy than linear regression. In the model, random forest gives high precision compared to logic linear regression, and both the models have similar recall values.